Space often looks calm and unchanging. When we look up at the night sky, everything seems fixed. Stars in the same positions, the sun rising and setting on schedule. But in reality, space is anything but still. Our entire solar system is moving around the center of the Milky Way at about 220 kilometers per second. At the same time, nearby stars are also moving, sometimes passing relatively close to each other over long periods of time. So even though everything looks stable from Earth, the structure of a solar system is actually the result of a very delicate balance. Which raises an interesting question. What would happen if that balance was disturbed, and Earth was pushed out of the solar system? To understand this, we need to look at how Earth stays where it is. Earth orbits the Sun at roughly 30 kilometers per second. This motion is balanced by the Sun's gravity, which constantly pulls Earth inward. This interaction is explained by gravity. Instead of falling directly into the Sun, Earth keeps missing it because it's moving forward fast enough. That's what creates an orbit. If either of these factors changes, the speed or the gravitational influence, the orbit can become unstable. There are several scientifically supported ways this could happen. One possibility is a close encounter with a passing star. Over millions or billions of years, stars move through the galaxy and can come relatively close to other systems. If a star passed close enough to our solar system, its gravity could disturb planetary orbits. Another possibility is a gravitational interaction with a massive object, where energy is transferred between bodies. This is known as a gravitational interaction. If Earth gained enough energy from such an interaction, it could exceed the Sun's gravitational hold and escape entirely. This idea might sound extreme, but it's not unique. Astronomers have discovered many rogue planets drifting through interstellar space. Some studies suggest there could be billions of rogue planets in our galaxy alone. Most of these planets likely formed in solar systems, just like Earth, before being ejected by gravitational disturbances. So in this scenario, Earth wouldn't be doing anything unusual. It would simply be joining a very large population of planets already out there. Interestingly, the answer is no. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth. That means even if Earth were ejected instantly, we would still see the Sun exactly as it was, for those 8 minutes. During that time, everything would appear completely normal. There would be no visible sign that anything had changed. After those 8 minutes pass, the difference becomes noticeable. The Sun would no longer move across the sky in the usual way. Instead of following its predictable path, it would begin to shift position differently, because Earth is no longer orbiting it. From our perspective, it would look like the Sun is slowly drifting away. In reality, it's Earth that's moving, in a straight line, away from the solar system. Even after leaving the solar system, Earth wouldn't stop moving. It would continue traveling at roughly 30 kilometers per second, the same speed it had while orbiting the Sun. This is due to inertia, the tendency of an object to keep moving unless acted on by another force. Without the Sun providing the centripetal force needed for orbit, Earth's path becomes straight. At that point, Earth officially becomes a rogue planet, traveling through interstellar space. The most immediate and important consequence isn't motion, it's the loss of energy. The Sun provides nearly all the heat that keeps Earth habitable. Without it, Earth begins to cool. However, this doesn't happen instantly. The oceans and atmosphere store large amounts of heat, which slows the cooling process. Even so, the drop is significant. Within a few days, global temperatures fall below freezing. Within weeks, most regions experience extreme cold. Within a year, average temperatures drop to around -70 degrees Celsius. Over time, the planet becomes increasingly inhospitable. Despite the extreme cold, the oceans wouldn't freeze solid right away. Water has a high heat capacity, meaning it can retain heat for long periods. Instead, the freezing process happens in layers. Ice forms on the surface first. Over time, the ice layer thickens. Liquid water can remain underneath. Some models suggest that these subsurface oceans could stay liquid for very long periods,
thanks to heat from within the Earth. Life on Earth is heavily dependent on sunlight. Without it, photosynthesis stops almost immediately. This leads to a chain reaction. Plants die. Herbivores lose their food source. Carnivores lose their prey. Ecosystems collapse step by step. Oxygen levels would also begin to decline over time, since plants are a major source of oxygen production. Some forms of life could survive longer than others.
On Earth today, there are organisms that live in extreme environments, including deep-sea ecosystems that rely on chemical energy instead of sunlight. These ecosystems exist near hydrothermal vents, where heat and chemicals from the Earth's interior support life. In a sunless Earth scenario, these environments could remain active for a long time. Humans would not survive on the surface under these conditions. However, survival might be possible underground. Earth still produces internal heat through radioactive decay. Near geothermal regions, temperatures could remain relatively stable. With advanced technology, small groups could potentially survive using geothermal energy-controlled habitats, artificial food systems. But over very long timescales, even this becomes difficult. As Earth continues drifting through space, temperatures drop further, and internal heat gradually decreases. Eventually, Earth would become a frozen, inactive world, a rogue planet moving silently through the galaxy. Final ending. Earth's position in the solar system depends on a precise balance of motion and gravity. If that balance were disrupted, the result wouldn't be immediate destruction, but a slow and unavoidable transformation. And it highlights something important. The conditions that allow life to exist on Earth are not permanent. They're the result of a very specific and fragile arrangement in